Good morning. This is Gary, Whiskey 4 Echo Echo Yankee. Welcome to my workshop. It's about 80 degrees outside and about 40% humidity. My workshop is open to the outside, so if you hear noises and whatnot, that's the reason why. Why we're here today is to do a little test of some RF HF watt meters, some high frequency watt meters. I have 4 units to test today, and we can compare them also with the metering in my power amplifier and in my Yaesu transceiver. I'm doing this in anticipation of building another RF 2K plus linear amplifier for Cal Harris, K1CAL, and I wanted to use these meters as part of the alignment procedure. I'm also interested to see how my RF 2K plus watt meter calibration compares to what the meters are indicating. I'm suspecting that it's off, and I'm thinking that after going through this, we'll have a chance to maybe make some improvements and recalibrations in that unit. So the setup today is a Yaesu FT-DX1200. We'll be using that as the exciter, as the RF signal source. We'll be using the RFKit.de model B26 RF 2K plus linear amplifier, a legal limit amplifier. We'll be running that through, and these are all series connected. This is an LP100 digital vector RF watt meter, an Elecraft W2 RF watt meter, a Daiwa NS-660PA, which was a Hamfest find at the Dayton Hamfest. Got this home and discovered it didn't work and had to make some repairs, but made it so that it's operational. I have no idea when the last time this unit was calibrated. And finally, another Daiwa cross needle indicated watt meter. This is the model CN901, which I found at a special price new at the Dayton Hamfest. Having bought it, now I've read on eHam some of the reviews, not so complimentary. But anyway, I'll be interested to see how these units will perform. So we're going to go through a low power test, a medium power test, probably around 300-400 watts, and then a high power test to see how the meters compare. And finally, we'll set up a mismatch. I'll put a second dummy load in parallel, and we'll see what the VSWR indicated is on the meters. I have swept the system right now. We are using an MFJ dummy load, Versa load, and the VSWR as measured on my Rig Expert AA54 is below 1.2 to 1 across the HF bands. So we should be okay there. I didn't mention also I have a Rigol, a DS1054 digital storage oscilloscope, also connected to a test point that I added to the dummy load. We're using the ×10 probe. We're going to be measuring voltage using its peak-to-peak voltage measurement function, and we'll do some calculations by hand to see what the oscilloscope is saying is the indicated power going to the dummy load. Now, the last time the Rigol was calibrated, I have no idea. I bought that at the Orlando Hamcation Hamfest a number of years ago. So let's get started with some low power testing. So we're operating right now in a 40 meter frequency, and we have the ability to adjust the RF output of the Yaesu FT-DX1200, and I'm going to set it for 30 watts. 30 watts indicated. We're using CW, and on the W2 watt meter, I'm going to move the range to the 200 watt scale, and on the Daiwa units, I'm going to move the range switches, which are manually selected, to the 300 watt scale. And we're operating at 7.036 megahertz. 30 watts is indicated on the power output of the Yaesu. So looking across, I'm reading on my amplifier, which the amplifier, even though it's not in line, will read. And the metering says 30 watts. The digital readout says 27 watts. Okay, we're in the ballpark there. On the LP100A, it's saying 28.8 watts with an SWR indicated of 1.07 to 1. The Elecraft, which uses LEDs, and so the resolution here is not real great. The Elecraft W2 is indicating about maybe 2.5 LEDs illuminated from where I'm looking here, and a very low SWR. If you were using the software, I have the software for the Elecraft, and if we were connected to it, we'd get much finer resolution. It's just the display on the device that's not very precise. And so if I move over here, on the Daiwa NS-660PA, we're indicating between 2 and 4. I'd say it's indicating probably about 35 watts forward power, no reflected power. And on the CN901, we're indicating about 22 watts. So the loser in this case is the CN901. It is probably the least accurate. Over on the oscilloscope, as I move over here, it's indicating a peak-to-peak voltage of 120 volts. So I'm going to make a note of that. So I'm taking the Yaesu out of transmit, and we're now going to move to what I call a medium power test. I'm going to crank the RF output power of the Yaesu down to 5 watts, and I'm going to put the amplifier into operate. I know that this will get us, with 5 watts into the amplifier, this will get us around 300 watts output power. And we can adjust this a little bit, but let's see what the meters are reading. But first, on the manual meters, I have to readjust the scale. So on the 2 Daiwas, I'm going to move them over to the 3 kilowatt scale and 3 kilowatt scale. And on the W2, I've got the range up to the 2 kilowatt scale. The LP100A is completely auto-ranging, and it'll have no problem whatsoever. So let's put some RF to the amplifier. The amplifier is indicating 420 watts output on the digital scale, and it's indicating a standing wave ratio of 1.1 to 1. On the LP100A, it's indicating 352 watts output with a standing wave of 1.01 to 1. On the Elecraft W2, we're indicating roughly 300 watts output. 3 LEDs are illuminated, and very low SWR. On the NS-660PA, we're reading about 380 watts output. Not a very precise ability to read there. And finally, on the CN901, it's indicating under 300 watts, probably 275. So again, the CN901 is the least matched to the other devices. Looking at the oscilloscope, we're seeing a peak-to-peak voltage of 376 volts. Going to let things cool down a little bit. Here then on this 40 meter frequency, what I'm going to do is adjust the RF output power to see if we can get close to 1500 watts out. We're going to then kind of pulse this up and down. The dummy load will take 1500 watts, but only for brief periods of time. So we may go up to 1000 watts. Try that first and see how things turn out. If I start boiling the mineral oil out of the dummy load, then I'll know we went too far. So there on the amplifier is indicated roughly 1,000 watts output. SWR is well about 1.2 to 1 indicated on the amplifier. On the LP100 it's saying 742 watts out, very low SWR. On the W2 it's saying 700 watts out. On the Daiwa it's indicating probably about 700 watts out. And on the CN901 it's about 700 watts out. And on the oscilloscope we're reading peak-to-peak voltage of 548 volts. And by the way, the drive power to achieve this is actually 12 watts. 12 watts out of the Yaesu. So let's let the dummy load cool down just a little bit. I'll remove RF, and then we'll see what the amplifier can do here if we can get up to indicated 1,500 watts, and then we'll see what the other meters read. I did reach over and touch the dummy load. It is warm at the top, cool at the bottom. That's, I guess, how the thermal distribution is on this dummy load. So let's briefly see if we can take it up to legal limit and see where this puts us. Interestingly, if you see something on the lens of the camera, I'm watching there's a very large ant that is crawling around on the camera at the moment. All right, let's go. So there's 1,500 watts indicated on the amplifier. Now the LP100 says that's 1,000 watts out, 1,056. The W2 rather says that's 1,000 watts out. The Daiwa says it's 1,000 watts out. That's the NS-660PA. And the CN901 also says 1,000 watts out, and 628 volts peak to peak. So as I mentioned, the amplifier calibration is off. I figured that would probably be the case. It looks like the watt meters are tracking fairly well at this high power level. And so I'm going to now adjust to try to get 1,500 watts indicated on the LP100 and walk across the meters and see where we are. So my amplifier display is indicating an output power of about 2,000 watts. That's not the correct number though. We're reading about 1,300 watts on the LP100. We're reading about 1,400 watts on the W2. We're reading about 1,300 watts on the NS-660. And we're reading about 1,300 watts on the CN901. And volts peak to peak is indicated at 744. So there may be an issue with my amplifier not being able to put out legal limit power on the 40 meter band. And this is another thing that I wanted to check out. Now this is an earlier version of the RF2K Plus using the 188 devices. They're now coming out with the 189 LDMOS devices. And so something to look into. Reinhardt, if you're out there and watching, I'll be in touch. Also, Mark, we'll be in touch. All right, I'm going to now add another dummy load in parallel, and then we'll see if we can read accurate VSWR across the meters. And then I think we'll stop there. This video is getting long enough. I could try this in different frequency bands, and I probably will. But I just wanted to give you a sense of different metering and different readings and different accuracies. So stand by. Let me install the second dummy load. So we're back, and I've connected a second dummy load in parallel with the first. I do have to say that the first dummy load was very warm, so I would not recommend that you attempt this at home unless you're very, very careful. We're trying to be very careful here, but I am probably at the ratings of this dummy load by running the high power into it. Let's now make a check at low power. We'll set the Yaesu back to 30 watts. The amplifier is in bypass, and let's see what the indicators read as far as standing wave ratio. By the way, I did sweep the system using my Rig Expert, and it is indicating a 2-to-1 SWR over a wide range of frequencies in the HF band, with a dip and a peak here. So the amplifier bridge is reading an SWR of 2.3. The LP100 is reading an SWR of 1.81. The Elecraft is reading an SWR of 1.7 to 1. I need to move down in scale here. The Daiwa NS-660PA is indicating a 3-to-1 SWR. No, I have to read this. I'm sorry. That's reflected power. 2-to-1 SWR, so that's on the money. And let's go over here to this guy. And the CN901 is reading an SWR with a cross needle display of about 1.9 to 1. Power's off. We're going to take the power level down to 5 watts on the Yaesu. We're going to put the amplifier back into service. We're going to put the range. Okay, that's good. We're going to put the range up on here and put the range up on here. All right, with the amplifier in, still indicated SWR of 2-to-1. On the LP100, we're seeing 300 watts out. Oh, let's go back to the amplifier. We're indicating 400 watts out on the amplifier. On the LP100, we're seeing 300 watts with an SWR of 1.84 to 1. On the W2, we're seeing indicated about 200 watts out with an SWR of 1.7. The Daiwa, let's see if I can take it to the 300 watt scale. Okay, with the cross needle displays indicating SWR 2-to-1 with 300 watts out. I'm going to do the same over here. SWR 2-to-1, and just for grins, 252 volts peak to peak indicated. On the oscilloscope. And I'm going to now take it up to 1,000 watts, and that'll be our final reading. 1,000 watts indicated on the amplifier. And I got an error message on the amplifier. Likely due to the SWR. So there's 1,000 watts indicated. Okay, and I get an error. The amplifier does not like that. So we're going to run it a little bit lower than that. So indicated about 796 watts, 800 watts, let's say, on the amplifier, SWR 2-to-1. On the LP100, it says 552 watts out, SWR of 1.87. The Elecraft, 500 watts out at 1.7 SWR. The Daiwa NS-660 says about 600 watts out, and the cross needle display is very difficult to read, but probably around 2 to 1. And, oops, I got the wrong scale here. Let's go to the right scale. Indicated about 450 watts out, and cross needle display, again, difficult to read, a little above 2 to 1. And working out the math from the oscilloscope readings, where we measured voltage of 120 volts peak to peak across the dummy load, that equates to 35 watts when you do the math, RMS. It was indicated 30 watts on the amplifier. 400 watts indicated on the amplifier gave us 353 watts out on the oscilloscope. 1,000 watts indicated on the amplifier gave us 750 watts out as indicated on the oscilloscope, and 1,500 watts gave us 985 watts indicated on the oscilloscope. Finally, 2,000 watts indicated on the amplifier, which shows the amplifier calibration is off, which is what I suspected. We got 1,383 watts out indicated using the oscilloscope. This probably hasn't cleared up anything. Rather, it may have muddied the waters somewhat. But I just wanted you to know that different pieces of test equipment may be calibrated differently, may have different accuracies, different tolerances, and so if you have a higher priced piece of equipment like the LP100, you can probably trust it to give you an accurate indicator of what's going on. Some of the other less expensive, in particular in this case the Daiwa CN901, it seemed to be okay at the higher end of the ranges, but the lower ends were somewhat out. Thank you for watching this high-frequency RF power meter shootout. It's getting warmer here, so we're going to shut down and look for you a little further on, and we will be building another RF kit amplifier, so please watch for that video coming up shortly. 73 from Whiskey 4, Echo Echo Yankee.